8.5. Let's go ahead and take a look at this warm-up. Don't forget you are going to put this in your Algebra 1 folder. You need to copy down what I'm writing, and you need to do some on your own. Remember, this should be completely filled out when I look at it in your folder. So this first one, it says type f of x equals x squared into line 1 of Desmos. So you're going to open Desmos, okay, and you're going to type that in just like it said to, and it's going to show you this graph here. I can close it, but that's what the graph looks like, okay? Notice where it's at. Notice where your vertex is at. Where does it say your vertex is? 0, 0. Then you're going to type each of these following functions into line 2. Okay, so you're going to take that and you're going to type it into line 2 exactly how you see it. So like for example, say I'm going to do this one on my own, okay? I'm going to type that in just like that. And I actually think we can say x squared minus 3. Okay, you don't even have to put the g of x. You can just put x squared minus 3. Notice what happens. It went from 0, 0 to 0 minus 3. What happened from there to there? It went where? Where did it go? What direction? It went down. So it went down. I'm going to change this. Down. How many units did it go down? 3 units. Okay, so I want you to try that on all of these just using Desmos and just notice what happens. Write down what happens. What happened when I did f parentheses x plus 5? Tell me exactly what happened from your graph, from that vertex to the next. Okay? Desmos is your friend. Use it. And then just kind of write down what you see. So that's your warm-up, and I do want you to try that on your own. Let's go ahead and move on because these warm-ups are going to help you kind of start seeing a pattern. But let's talk about the rules that create this pattern. So vertical translations, what we're going to look at first, but remember if I'm looking at a graph, okay, like this one, I'm going to zoom out a little bit. If I'm looking at a graph like this one, your vertical line is your what axis? Your x axis. So if I have a graph that looks like a graph, normal graph, right? Here's my x-axis, I'm sorry, my y-axis, I've already messed up. Here's my y-axis, that's my vertical, okay, up and down, y-axis, all right? My x-axis is my horizontal, okay? It is going left and right. That is my x-axis, and that's my horizontal. So when it says vertical translation, that means it's traveling along which axis? Your y. So a vertical, that's not what I wanted. Your vertical translation, okay, is traveling along the y axis, okay? It's going up and down because that's what happens on the y axis, right? When you see a function that is a vertical translation, it will be outside of the parentheses, okay? And it tells the truth. When I say truth, what I mean is when you see a positive or a negative, you can normally think, well, positive's up and right. Negative is down and left. It tells the truth. When it says plus 3, it means up 3. When it says down 7, it means, or sorry, minus 7, it means down 7, right? It tells you the truth. So your functions typically will look like this, right? So you'll see it where this plus d here is not inside of a parentheses. So that is telling us an honest shift, right? It's telling the truth. So for example, whether it's set up like this or like this, plus 3 means up 3. Same thing here. Whether it's set up like this or like this, minus 7 means down 7. So if you see it outside of the parentheses, it's traveling along the y-axis, and it's telling the truth. Positive is up, negative is down. All right. But let's take a look at the horizontal translation. Well, horizontal translation is left and right. So traveling along your x-axis. But this time it's inside of the parentheses and it lies. Okay, what it means by lies, well, typically, like we said, if we think negative, we think left. If we think positive, we think right, but it's lying to us. So really, -2 is right 2. When you see a horizontal translation, it'll be set up like this, where you see it inside of the parentheses. So this -c, right, that is a horizontal translation following along the x-axis. So when it says -2, whether it's set up like this or like this, it's actually going right 2 because it lies to us. This one, if it says +6, remember it lies, what direction would I be going? Left, right? No, I'm sorry, left, correct. So we're going to put this into practice and look at functions and decide what shifted, what happened. Now you can confirm any of these inside of Desmos if you're unsure, right? But let's take a look at a few without Desmos and then we'll double check. So it says the graph of f of x squared was transformed, right? And I already showed you what that looked like on Desmos, right there. Now it's saying what happened to that on this first one is x plus 2. Well, remember, if it's inside of the parentheses, that is going to be what? So, all right, I'm going to write that down. You don't have to write down this part. This is more for me. Inside parentheses, all right, inside P. So I'm going to go look. Oh, inside means it's going along the x-axis, so it's left and right, and it lies. So I don't know. I know it's going left or right, but if it says +2, what direction would that be if it's lying to me? Left 2. So left 2 units. And that's all you do, right? That's all I want you to put. This one, is this right here, is it inside of a parentheses? It's not, so it has to be a vertical translation, and it tells the truth. So when it says -4.5, it means down 4.5 units. And that's it, you're done. That's all I want you to solve on that. Now take a look at this one though. What is already different about that one? What do you notice is different? It has both, right? We have a horizontal shift and we have a vertical shift, but that's okay because it still follows the exact same rules. Inside the parentheses is left and right, and it lies. So +5 is left 5 units. And because we're not done, -3, it's outside the parentheses, so it tells the truth, down 3 units. And you're done. That is the transformation that happened. And you can even double check that by putting it into Desmos. And you can tell me exactly what happened there. I want you to try these 3 on your own. You're going to try this one, and this one on your own. And again, you can use Desmos to help you. Let's go ahead and go look at the next page. If I'm moving too fast for you, remember you can change the playback speed. You can pause. You can email me and say, Ms. Bailey, can you clarify this? I have no idea what you're talking about. And I'll do it, right? I'll help you out. I want you to succeed. I want you to do your best. All right, so let's take a look. This is exactly like what we just did a minute ago, but what's the difference here? Here, it gave us the function, and we wrote down what happened. This time, it wrote down what happened, and now we write the function. But you're thinking to yourself, maybe, Ms. Bailey, I have no idea how to write a function. It's pretty simple. All you have to do is make it look like this, right? Or even better, look like this. You just have to make sure it follows this rule or this rule, depending on what it says it did. So let's take a look at this first one. I'm going to go ahead and highlight some important stuff. The graph of f is translated 4 units to the right. So this is a horizontal shift. So that means it needs to either look like this or like this. So I'm going to go ahead and start that. I'm going to say, well, g of x, okay, is equal to, I'm going to go take a look at it again. It's got to be in the parentheses, right? Because it's right or left, so it has to be inside the parentheses. So I can do it parentheses x and then close parentheses squared. Now I just have to decide what goes inside that parentheses. Well, it says 4 units to the right. But remember, inside of the parentheses lies. So instead of saying plus 4, it's actually minus 4. And that's it. You're done. You wrote the function. Okay? And you can check it. If I put this into Desmos just like this, it will show me if I went to the right 4. And it will, right? And we can look at an example on Desmos in just a second, but let's take a look at this one together, okay? The graph of f is translated 3.5 units up. Remember, up and down is your y-axis, and so this is a vertical translation, which means it's outside. So remember, still g of x, but remember it should look something kind of like this or this. So I'm gonna follow this method right here. I'm gonna say x squared, and now what goes to x squared? Because there is no parentheses, 3.5 units up. If it's a vertical, it tells the truth, so it's going to be plus 3.5, and you're done. That is the function. Again, I could check it on Desmos. You are going to try this one and this one on your own, and I want you to try this one on your own. Okay, but let's look at this one together. The graph of f is translated 4 units left and 2 units down. So same process. I'm going to start with g of x equals. Now remember, if I go left and right first, let's start with that first. So here's my parentheses, just like I did up here. And then x, and then I know it's something squared, and then I'll have the rest of it, but now I need to figure out what those numbers are going to be. Well, I know it's 4, right? It shifted left 4, and it lies when it's inside the parentheses. So it's not minus 4, it's plus 4. It's kind of the opposite of that first one we did. Now I can go outside the parentheses because it's a vertical translation. It says 2 units down, and it tells me the truth, so I'm going to say minus 2. And now let's take a look at that and put that into Desmos, exactly how we see it there. Parentheses, remember you don't have to do the g of x, you could just put x plus 4, x plus 4, parentheses, squared, minus 2. And I'm going to zoom in here, I'm going to close that, I'm going to zoom in, it's kind of ugly, but look here to here. Did we go to the left 4? We did. Did we go down 2? We did. So we did everything perfect, right? It just looked a little funny because when you stretch it out this, it looks really crazy. But we did everything right. Your vertex went from here to here, exactly like it said it would. So remember, Desmos is your friend. I want you to try this one on your own. It looks a little funny because this is actually from a practice STAR test, right? I want you to try this. Remember, you can use Desmos, but think about your rules. Try that one on your own. All right, let's look at these bottom two. Example 1 and example 2. On example 1 here, this time it kind of changed stuff up. It says k of x and p of x, but guess what? It means the exact same thing. Do not panic when you see these different letters. It is the same exact rules. Nothing has changed. What is the value of n? So we know it's a vertical shift, right? Because it's outside the parentheses. So I know it's vertical. I know I have to go up and down. But remember, if this is what my original graph looks like at 0, 0 here, well, take a look. I went from 0, 0 right here, and then I went down. So already I know it's going to be a negative number because I went down and it tells the truth. And then look where it landed at -6. So your n has to be minus 6 because it shifted down 6 units. I want you to try example 2 on your own. Try your best.